Hi, this is Jonathan Homa from ECI. Welcome to today's webinar that we are conducting with Géant, which we entitled, somewhat provocatively, Open Optical Systems. Just because you can doesn't mean you should. As a starting point for this discussion, let's talk about what we, or you, as a person who runs a national research and education network, or just a research and education network, are trying to achieve with your optical backbone. So certainly it's part of an overall network, which is both an optical layer and usually a data layer as well, of course, that supports innovative ICT applications for your researchers, for your educators, for your users, and the various institutions that they're contained within. So it's there to support research and education. Typically in your network, you would have dozens of nodes, hundreds of links, and when you're speccing out what you need in your particular network, you will specify all sorts of items under the categories of performance, flexibility, control, availability, and of course, at a reasonable cost, meaning that it should fall within budget. So when we're talking about open optical, we should always bear in mind to what extent should this be applied to meet the needs of your particular network. And we're going to keep coming back to that particular point. So the challenge that you have is to what extent should you use disaggregated optical solutions to build your optical backbones for your NRENs. And today there's certainly a lot of activity taking place in and around open optical systems. As an example, there's open line systems which entail ROADMs and amplifiers. You have DCI or data center interconnect pizza boxes, where you have very densely packed series of transponders or muxponders for very high performance point-to-point communication. And then even things such as white boxes, which you would see in the TIP project, for instance, where people would have disaggregated software and just really, really basic levels of hardware, and even further down the value chains in terms of how far you can go with disaggregation. So certainly there's more and more options that are available out there to you today in terms of being able to assemble open optical systems. The question is, what should you be doing in the case of your particular NREN? And what I'll do today is walk through a number of these different examples and go through the various trade-offs and see, and then you can start judging for yourself what might make sense for you. Before we do that, though, I think it's worthwhile taking a step back and asking, what is the motivation for doing this? And there was a survey that took place last year by IHS Markit, and this is the highlights in terms of the responses from the various people that took the survey. This did take place only in the US, so you can't really consider it a global survey, but I think it's pretty indicative of what people would be looking for. So really what it boils down to is people want freedom. You don't want to be tied into a specific vendor, and you want to have flexibility and control in terms of managing the evolution path of your network. In terms of specific responses, people say that they want to have open systems and vendor independence because they want lower CapEx. There was always that feeling that if you're pitching one vendor against another, you're going to end up with a better price through negotiating power. People want open systems, again, with powerful APIs on top of them so that they can be controlled and you can gain the benefits of SDN. Reduced vendor reliance is more along the lines of the first one in terms of lower CapEx. And then there's the last one, lower OpEx, which I'll be honest, I don't fully understand, but I guess people would figure out that if they can control their own systems and customize them the way that they want, that they'll end up with lower operating costs. So these are the general motivations that people have to pursue open optical systems. Now, what are the various pieces of the puzzle that we can put together in terms of assembling these systems? So at the bottom part of the screen, we actually have the optical systems themselves. We have the transponders and the muxponders that's responsible for sending and receiving the optical signals. We have the ROADMs, which could also include passive MUX and DMUX, but the ROADMs as an active component are used for routing the optical signals. And then we have the amplifiers, again, which are an important part of the overall optimization of the system in terms of making sure that you have the best performance in terms of the transmit and receive. So this is the part of the system that's responsible for actually sending and receiving the optical signals. But on top of that, and we certainly can't ignore, all this needs to be controlled. So in a traditional hierarchy today, we'd have EMS, element management systems, and network management systems, all evolving towards some kind of centralized software-defined networking control systems. And this is responsible for managing the resources in the network, for provisioning them, and then for ongoing management, monitoring, on-the-fly reconfiguration, alarms and fault handling, etc. In other words, making sure you have a smooth operation of your network. On top of that, I've added another layer, which I call OSS BSS, or service orchestration. And again, the goal isn't just to run an optical network. The goal is to run an overall services network. So you have the packet layer that takes place on top of that, or the IP layer. And more what you're looking to do is run the packet layer and the optical layer under a common umbrella that you can get the most bang for the buck out of your network in terms of providing services to your end customers. And then finally, we see the little jigsaw puzzle piece on the side, which is support, which means when something goes wrong, you need to turn to someone. And that's usually going to be the vendor of your system or the vendor of the particular modular component in a disaggregated system. So let's start taking a look at how these things can all come together. So we'll start off with the case which I would call the prevalent case today, which is no disaggregation. What you're doing is you're turning to a single vendor to supply the entire network. And in this particular case, you see all that network in blue, all the various nodes which pull together in systems, your transponders, your muxponders, your ROADMs, your amplifiers, that little box on top which says CE, it's common equipment. They all come together in terms of some kind of network control system provided by the vendor. And then that vendor could provide today an API or application programming interface to a higher level of OSS or BSS and orchestration that would be provided by the NREN. And more we're seeing the direction whereby people are specifying the kind of controls that they would want at a network level in terms of being able to provision paths across the network, being able to monitor what's going on across the network, being able to reconfigure the network dynamically in case something goes wrong. And all these can be provided through a network level API. In this particular case, I'm only showing a single jigsaw puzzle piece. There's one vendor, something goes wrong in the network, you know who to turn to for support. What are some of the benefits of a system with no disaggregation? So I'll be clear, you're not achieving the objective of vendor independence. You're very much dependent on a single vendor, although there are certain benefits towards doing that, particularly since when we're dealing with optical networks, we're dealing with an analog system. Excuse me. So in an analog system, there's a lot of knobs and tuning that need to take place in order to get the maximum performance from that system. So for instance, balancing the amplifiers, equalizing the signals on the ROADM, and then in particular, really gaining the most performance in terms of the transmit receive, in terms of the various forward error correction settings that are used on the transmit path. And today, when you go into a single vendor, of course, they'll be using some proprietary level of these FEC settings in order to maximize the performance on the links. When you're dealing with a single vendor, it also makes it much easier to optimize maintenance, to integrate monitoring for optical signal to noise ratio, for integrating features such as optical time domain reflectometry so that you can find out when something goes wrong on a fiber where the fiber break is, and also for implementing coordinated restoration, whether it's at an OTN level like ASON or at a WDM level like WSON. But putting this all together, a single vendor can control the entire network with additional intelligence and features that they would provide, that you get a really well performing network end to end. And like I said, this is primarily the case today. there'd be a single network control system, there'd be some level of APIs on top of that, going up into an NREN orchestration system. Now let's step down and take a look what happens for a first level of disaggregation. So in this particular scenario, what we have is several vendors. So the systems are still aggregated at a system level. You still have a set of transponders, ROADMs, amplifiers, all put together in a single system. But what would happen is within a NREN network, you could have several vendors providing their systems living side by side. Now, here you're getting into some hierarchy of network control. So you would have, for instance, one level of network control for vendor A, another level of vendor control for vendor B. These can be provided by the vendors or perhaps by the NREN themselves, as long as the application programming interfaces are published and understood at the system level. So here, what I've pointed out, it's extremely incumbent on the suppliers or the vendors to create models of how their network works, and people are going more and more towards Yang modeling for that, and then providing interfaces such as a netconf interface to a network control system that these can be controlled easily by third parties. And again, like I've mentioned, we can have different levels of responsibility in terms of who's actually implementing the network control systems, but as long as the system level APIs are well defined and published, this is something which is fairly doable. So how would this look like in a network? So one likely scenario that NRENs might start to adopt is similar to what a lot of larger service providers are adopting, which is they're assigning different geographical domains of the NREN to different vendors. So over here, I would show 3 different vendors. You have one in blue, one in green, one in yellow, and each of these are assigned different geographical areas of the optical backbone. They each come into their own network control system, and then these network control systems are aggregated at a higher level of orchestration. And again, this is something which is fairly common in service provider networks today. One thing worth pointing out in this kind of scenario is when you do have multiple vendors' equipment, in many cases, what you're going to want to find is, for some particular reason, you'll have a signal starting off with one vendor, and then you're going to want to run it over someone else's network and then end up on the original vendor's equipment. And this is something which is called alien wavelengths. So an alien wavelength means that you're running someone else's optical signal using a transmit-receive pair over another party's optical line system. And one of the scenarios, and this came fairly sort of evident at the workshop a few weeks ago in Trondheim, is that people are looking at a model of what I would call DCI over OLS, which is where they might have an established network in terms of an overall, say, from a single party, but what they want to start to do is now use only the open line systems or the ROADMs and the amplifiers of that particular party, but run the transmit receive of another vendor over that. In this particular case, using things such as DCI or data center interconnect boxes. And what I really want to point out is that there's nothing particularly new over here. This is something which is fairly doable. People have been doing this for years, and it really falls under the title of alien wavelengths. So this is a form of disaggregation that's already being used, and I think will continue to be used, even though we might provide a bit more structure in terms of doing this, in terms of what we call DCI over OLS. A few other things worthwhile pointing out, though, in the scenario of having multiple vendors in a common network is that of optical interworking. Now, there is a project, for instance, starting off about a year and a half ago called Open ROADM. And as part of Open ROADM, they're also specifying how to perform connectivity at the optical level itself, in terms of you could actually have a transmitter from vendor, say the blue vendor, and the receive side could be provided by the yellow vendor. This is something which they're aiming to achieve, but there's a certain level of consensus in the industry that, again, while this is technically possible, that there are certain reasons why you probably don't want to do this. One is, there's a problem, who do you go to? It's particularly troublesome to troubleshoot problems on the actual link itself, in terms of, is the problem on the transmit side or is the problem on the receive side? The other problem is, because you can't tune this all under a single umbrella, what it means is that you're going down to a very low common denominator in terms of your forward error correction settings, which means that you're really not getting the maximum performance out of the link that you can. So this level of optical interworking between different vendors in a multi-vendor network is something which is particularly problematic. Now that has implications. So what are the implications? One is that you'll probably need to re-architect some of your network, maybe to eliminate certain of those links where you would previously have that kind of optical interworking. Or what you need to start doing now is introducing OEO, or optical elements, that you're coming back to a common electronic denominator and interworking at the electronic level as opposed to at the optical level. So that could introduce new costs. Or, as I indicate on this particular screen in the bottom and the middle, you can do the interworking, but you're not going to have optimal performance. And if there's a problem, it's going to be difficult in terms of knowing who to turn towards. So again, this is something which is fairly common in sort of large service provider networks. And these typically, in these networks, in almost in all cases, the interworking is taking place at the electronic and not the optical level. Now let's go to the final, what I would call highest level of disaggregation. And this is what I call open modules. So we had identified previously the fact that there's really three main types of modules within an optical network. You have your transponders and muxponders, you have your ROADMs, and you have your amplifiers. So in this particular case, what you have is an ability to provide different modules from different suppliers. Maybe this is sort of showing extreme case with all the different colors, but we'll come down in the example to something which is a bit more concrete. But theoretically, this is what you can do. You can provide a transmitter from one supplier, a receiver from another one, a ROADM from a third, and an amplifier from a fourth. Each of these would come with their own set of common equipment. Each of these would come with their own set of APIs in terms of the specific functionality of that particular module. And then these would all report northbound up to a specific network controller that that vendor provides, or that's provided, say, by the NREN based on the APIs. And it would be up to the NREN to start aggregating these different modules with their different functions in the way that they best see fit to meet the particular needs of their optical network. We also show, of course, multiple levels or multiple vendors providing support, or that you can turn to for support in the event of a problem. So what's our experience with this in the industry? Here what we're showing in the NREN diagram, if you take a look at the nodes, we don't have a blue node anymore, or a yellow node, or a green node. What you have is you have blended nodes where in each particular node, you could have different types of functions from different vendors all put together. And there is some sort of reference point for doing this in the real world. AT&T tried this in a very limited part of their network. They actually forced 3 vendors together. It was a very limited deployment. It was just a trial. It wasn't meant to be an extensive shift, but it was meant to see if it could work. And it did work, but it took what even AT&T reports was significant software development and system integration effort. And what I would maintain is, for this sort of highest level of disaggregation, it's probably at this stage something that would be too complex for RENs to consider implementing, at least on a network-wide basis, and I would say for the foreseeable future. Just the amount of network integration and testing that needs to take place probably prohibits that from being sort of a successful path in the near term. So is that really all doom and gloom for full disaggregation? And I would say no. I would say using open modules can make sense for certain applications. And here I've highlighted two particular applications where I would say there's more limited amount of deployment and where the amount of system integration that needs to take place also has a lower bar. So one particular case here, I've sort of isolated what I call data center to data center interaction, or pure DCI. What characterizes DCI is usually shorter path lengths, typically less than 80 kilometers, which means you don't need to use any mid-span amplification. Also, you have usually a very dense amount of links, which is why I've shown the optical path, at least the line there, a lot thicker, which means that expense can start to play a factor over here in terms of how you provide that solution. Because in many cases, when you're just looking at an optical path between any two nodes, maybe you're talking, say, about a half a dozen different wavelengths. When you're talking about DCI connection, sometimes you could be getting into the 10s or 20 of wavelengths. So the expense that's associated with a transponder and receiver pairs is something that you need to start considering a bit more. Another thing that you need to do is, another application which I pointed out here is ROADM hubs. You could have centers of excellence within your NRAN where you have a lot of optical links coming in together. You might just have people that need to have them for a short period of time. And so what you want to perhaps bring under your own proprietary umbrella is in terms of how you're providing switching or optical routing for that particular center. So you might just want to buy a specific, very customized ROADM solution and then manage that yourself. But coming back to the DCI example that I mentioned before, this can be a good example of how it's put together. You would turn to one vendor to provide the open line system, which in this particular case could be a passive, or maybe I should also show that as a ROADM, providing the MUX-DMUX functions, as well as with an amplifier, at least on the originate side. You don't need anything mid-span if you're only going up to 80 kilometers. And then you can turn to different vendors to provide your transmit-receive pairs. And here, I'm not advocating that you mix your vendors for the reasons that I said before. But again, you do have the capability to go out there and get different DCI boxes from different DCI vendors and swap these out as they keep competing with each other, perhaps, and sort of really drive down the cost and drive up the performance for this particular DCI application. So this is really a good place to start when you're looking at a higher level of disaggregation. There is a bit more that needs to be done, of course, on the network management and control side, but since it's a more constrained application, it's something which should be fairly doable. So at this stage, what I'd like to do is step back. We took a look at three different types of scenarios for disaggregation. One is what I call a single vendor network. Another is what I call is several network equipment vendors. And the third is multiple module vendors for niche applications. And let's see how well we are meeting the types of objectives that we set up at the beginning. So in terms of vendor independence, admittedly, a single network vendor is low. You're relying on a single vendor. When you have several NE vendors, it becomes obviously medium. They're competing more actively with each other. And then when you have the multiple module vendors, well, of course, it's very high. You can pick and choose whomever you want. Now, what about cost? Because cost is something which probably was the key driver. So in a single network vendor, you're probably getting a good cost. I mean, let's face it, there's still a competitive bid situation, at least at the outset. And what a single vendor can do is deliver certain economies of scale in terms of how they put the overall network together, both in terms of the line systems and the transceiver and receiver pairs. When you have several NE vendors, it's the same as a single network vendor, but they don't have the same economies of scale. So in theory, you might get a better initial cost because they might be more aggressively competing with each other for some of the business, but this has to get balanced out by the fact that they're not getting as much as the pie, and they have to recover that in a different way. So let's say it's a little bit better in theory. When you get to multiple module vendors, it's unclear whether you have an initial cost advantage. The reason for that is because you're buying different piece parts from different vendors, each of these have to come with their own common equipment overhead. And also the vendors of these equipment have no economies of scale. Now, if you're comparing apples to apples in terms of the equipment that you would get under a fully disaggregated system with some of the more higher levels of aggregation, it's could be difficult because some of the fully disaggregated systems might be totally stripped down in terms of any of the additional bells and whistles that you might have, for instance, such as integrated monitoring when you get within a more fully aggregated system. But it's feasible that within these niche applications that you will get better costs. What about the benefits of vendor innovation? Again, it's similar when you're talking about a single vendor. You're going to get very high level of vendor innovation for that network-wide application. And this is, again, coming back to the points that I made about analog systems and the fact that you can have all the features embedded in the system and controlled by a single supplier in terms of really extracting the maximum performance, availability, reliability from that particular network. When you have several NE vendors, it's limited to their domain, and then it's up to the NREN to try to start tying those things together across the overall network. For certain functions, such as end-to-end optical signal-to-noise ratio monitoring, that could be a little bit difficult, particularly if a wavelength spans multiple vendor domains. In terms of vendor innovation, for the niche applications, if you can really pick and choose what you're looking for from a particular vendor, say in terms of getting the highest level of link performance for a DCI application or the most number of links to route under a ROADM, well, then you can really go out and pick the best vendor for that particular job. The elephant in the room, though, which really didn't get talked about as much as it should have at the TNC workshop, was the amount of system integration effort that needs to take place. And I think that's an area where a lot of people that are looking to go to higher levels of disaggregation really need to step back and take a look at what's involved over here. When you have a single network vendor, that's all done for you by that particular supplier, and you might not realize all the work that goes into that. When you have several NE vendors together and you're having to sort of orchestrate them together under a common umbrella, again, I think you can start to see some of the work that needs to take place, particularly when you want to start presenting a sort of single GUIs with common look and feel to your network operations center personnel, and also dealing with situations where you have optical signals spanning multiple vendor networks and making sure that you have all the tools in place to monitor their performance, to troubleshoot them when things go wrong. So there is some level of investment that needs to take place, and it might be more than you would consider if you haven't done that kind of thing before. And the same sort of thing applies when you have multiple module vendors for those niche applications. When you're really dealing with multiple modules, it could be very complex, but at least if you're just talking about one or two links, say between data centers, at least it's on a smaller scale. And the final point I wanted to make here is just reiterate something I said earlier. Alien wavelengths. Alien wavelength is something which has been around for a number of years. It's whereby you're running one vendor's transmit-receive pairs over another vendor's line network in terms of ROADM and amplifiers. And again, this has been taking place for some amount of time, and to a very large extent, it achieves many of the goals of disaggregation if you particularly like one vendor's equipment for a particular application, say in terms of the kind of optical performance that it's providing. So to summarize the discussion today, I'll give you a forecast in terms of where I see the NREN community going for the next few years. And I'll limit it to 3 years because things are continually changing in our industry, and I really don't want to say what's going to go on beyond that. There's no question that there is an overall drive towards more open systems, more vendor choice, more amounts of control that will be implemented by the NRENs themselves. Nevertheless, this is how I see things playing out for the next few years. I think we'll continue to see, in most cases, continuation of the status quo, that NRENs will turn primarily to a single vendor for their optical backbone. What we will see, however, is an increased emphasis on the control that will be exposed by the network management system or SDN controller of that particular vendor northbound to higher levels of orchestration being provided by the NRENs. We will start to see, particularly in larger NRENs, awards going to multiple optical vendors, where perhaps they'll start awarding specific regions to a second vendor. And in this particular case, these are NRENs with the skill sets and resources to provide the necessary system and operations integration. And a lot of NRENs are starting to set themselves up to do that. And as they gain experience with building their own network management systems or SDN orchestration systems, that will make it easier for them to start incorporating many more vendors at the network level. We'll also start to see increased use of alien wavelengths. If you have multiple vendors, it doesn't mean that you necessarily need to constrain them all to a single region. What you can start to do now is start running different vendors' signals over the other vendors' networks. And then finally, we're going to go towards more fully disaggregated subsystems for niche applications like I described, particularly for point-to-point data center interconnection, where you might have a large number of links and you're really looking for a very specialized solution. So even though there's more network integration effort that needs to take place, it's on a more constrained basis and something which should be manageable. And with this, I will conclude my presentation and say thank you, and leave this slide up over here in case there are any questions. Carl, I can't see the question screen, so maybe you've been collecting something.
No, there haven't been any questions yet, but thank you very much, Jonathan. That's really interesting. I'm just going to ask if anyone has any questions. I'm going to actually going to make myself host again so I can unmute everybody so we can actually ask questions verbally. Hang on a second. Right, so we then unmute all. Okay, so does anyone have any questions for Jonathan? No. Do we have anything at all? No, absolutely. Well, I'm sure that some of the people were already at the workshop at TNC a couple of weeks ago. What I would say is, anybody who has any questions for Jonathan, please contact myself or Jonathan. I will send out his email as well directly after the event. If you'd like the recording of the video, then please drop me a line and I will share that out as well. And yep, absolutely, we'll be very, very keen to answer any of your questions. Oh, yes, we have one question coming through. Okay. I can't unmute you. Ridaza, could you type your question? Or if you could unmute yourself, that might work. Okay. Oh. Okay. So I think the question is that each individual NREN will be providing different services, and I'm assuming from the kind of context of the question that you're asking, how will those NREN to NREN services be integrated? Because obviously, if one NREN is offering one set of services and another NREN is offering a different set of services, how do they kind of integrate across the NRENs and presumably with GÉANT in the middle of that as well? That's always been one of our major bugbears in the RNE world. So do you believe that open optical networking will help this, or will it actually add another layer of complexity, Jonathan?
The optical network ultimately is just providing a connectivity path. Most of the services, at least in terms of the end user services, are being defined more at the data layer. And that to me is a separate discussion. Actually, there was another session on that at TNC where I just happened to speak at the same time as well. There was actually a program that was set up a few years ago by Géant, which was trying to address that. I don't know if some of the people on the call have heard of something called Autobahn. And
I know it well.
Yeah, and again, I think they got to the stage of a POC, but it never really progressed beyond that, from what I understand. But there are activities taking place in the industry today, particularly under the MEF, where they're describing something called lifecycle services orchestration. And as part of that, they're defining, they're building on the fact that the industry as a whole is putting a lot of attention in terms of north-south interfaces for control of network equipment and then for creation of services dynamically within a single service provider or a single operator domain. But what they're doing on top of that is specifying and building interfaces east-west between OSS and between BSS that different service providers are able to negotiate dynamically among themselves, irrespective of the fact that they have different underlying network infrastructures, as long as they have a set of common service definitions, say for such things as E-line services. What they can then start to do is trade all the information that's necessary for dynamically setting up these kinds of E-line services across service provider domains. And that's an area which is gaining a lot more traction these days in the service provider industry. And certainly at the session, it piqued a lot of interest among some of the NRENs in the room. So if people are interested in that, let them contact me and I'd be glad to send them information.
Fantastic. That's really useful.